The USS Iwo Jima is a crucial component of U.S. military strategy, particularly its operations in the Caribbean Sea.
The USS Iwo Jima, docked here, is a centerpiece of U.S. military strategy, particularly in the Caribbean Sea.
The radar system needs to be online before we leave dry dock.
Already accounted for, sir. We'll be ready by 0600.
The USS Iwo Jima represents the critical component of U.S. military strategy in the region, ready to deploy at a moment's notice.
We've optimized the system's performance metrics by 15%. Ensure the blueprinted schematics reflect the adjustments before the next cycle.
The schematic confirms the radar placement optimizes coverage.
Now, utilizing that data, how do we maximize the F-35 launch cadence on the flight deck?
This configuration optimizes the Harrier VTOL approach path significantly.
And minimizes interference with concurrent helicopter operations.
We need to optimize the starboard side elevator access.
Agreed. The current layout impacts aircraft turnaround time.
Zoom in on the flight deck schematics. We need to verify the structural integrity around the forward elevator.
Confirmed. The stress analysis reports are green. As we review the schematics, note how the flight deck design solidifies our strategic advantage in the Caribbean theater.
All right, ease the plate over to the left. Watch that hydraulic line. Got it. Clear on this side. Hold it steady while I secure these bolts.
The inspection findings suggest we need to recalibrate the sensor array.
Agreed. Let's get the team started on the replacement parts immediately.
The torque on this connection seems off spec. Let me verify the calibration on the wrench.
The data logs confirm the stabilization protocols are working.
Good, good.
Let's initialize the comm array test sequence.
Look at the telemetry on channel 3, getting a slight fluctuation during the stress test.
I see it. Rerouting the data stream for deeper analysis. It might be a software anomaly.
Frequency scan complete. Analyzing signal integrity now.
Clear the deck for launch operations.
How are the landing systems responding to the stress test?
All systems are green, replicating Caribbean sea state conditions now.
Adjusting frequency bands on the primary radar array now. Confirmed. Data stream looks stable at 5.8 GHz.
We're finalizing the radar sweep calibration. The diagnostic confirms the system is operating within optimal parameters for Caribbean theater deployment. We need to reroute this connection according to the updated schematic.
Understood. I'll secure the override cable. Securing the final conduit now.
Verify connection integrity on your end, then run diagnostics. Meticulous attention to detail is critical here. We verify each conduit connection to the missile system interface before initiating the diagnostic cycle.
Check the alignment on the propulsion coupling. We're showing slight vibration on the number 2 bearing.
Signal strength is fluctuating on the antenna array.
Run a diagnostic on the transceiver module. Let's see if we can isolate the fault.
All right, bring it left slowly. Hold your position. Set it down. Cargo secured. All right, bring it left. Easy now. A little higher. Hold it right there. Perfect. Perfect. Pallet 3, move it forward. Watch your clearance on the starboard side. Secure that load, double check the straps.
The deployment window is closing. We need this section loaded now.
Sir, the heavy lift manifest is incomplete.
Prioritize the forward elements and get this secured.
Coordinates are locked. We proceed as planned. Secure that pallet now. Move it faster. Crane approaching the flight deck. All hands stand clear.
We are behind schedule on the aft cargo hold. I need that section clear before 0800 hours or we miss the tide. That crate won't fit in Bravo section. The schematics are outdated.
We can reroute it to the forward hold if we shift the ballast.
Affirmative. Moving it now before the next lift arrives.
All cargo secured, sir. Ready for departure.
Acknowledged. Helm, all ahead full. Vultures, launch sequence initiated.
Iwo Jima Tower, Viper 2-1, requesting takeoff clearance for sortie.
Viper 2-1, cleared for launch. Good hunting.
Iwo Jima, this is Navy FA-18, commencing flyby maneuvers.
Hornet, you are clear for the high-speed pass. Maintain altitude.
Hornet 4-7, execute high-speed maneuver. Vector 390, Angels localized. Clear the deck.
Raptor 7 transitioning to full power.
Cleared for immediate takeoff, Godspeed.
Watch the clearance on that radar panel. Hold it steady, we're almost there.
Ensure the conduit is secured before we power up the array. Copy that. Running final diagnostics now.
Ensure the connection points are torqued to spec.
Copy that. Running diagnostics now.
Power levels look stable on this end.
Is the primary cable secured?
Yes, connection is green.
Proceeding to Module 3 alignment.
Torque the bolts to spec, B. Copy that. Wrench engaged. Propulsion coupling is secure.
The USS Iwo Jima's legacy is marked by critical amphibious assaults and advanced carrier operations.
Crossley. The USS Iwo Jima truly highlighted the critical role of amphibious assault. Integrated.
The advanced radar systems you see here revolutionized amphibious assault capabilities during the Cold War era.
Navigation systems are online and stable. Look at this return here.
I see it. Adjusting the gain on the ATC console.
Primary telemetry stabilized. Recalibrating the azimuth servo.
Readings holding steady at Mark II. Confirming alignment.
Verify the alignment sequence on the radar.
Confirmed. Moving to inspect the CIWS hydraulics.
Calibration sequence initiated on the phalanx.
Readings stabilizing at 98% efficiency.
Confirming green status on the ALSE interface. Calibration sequence complete. Locking gimbal axis now.
Confirmed locked. System reports nominal parameters.
Adjusting frequency hopping on the primary radar.
Confirming synchronization on the secondary display.
Looks good.
Reroute the primary conduit through auxiliary control.
That bypass won't clear the diagnostic cycle. Use the standard port.
Adjusting parameters now. Stand by for confirmation.
Thermal coupling is loose on Module Bay 3. Copy that.
Preparing the replacement unit.
That's the last one. Connection checked and secure.
Verify the conduit connection is seated properly.
It's locked in. Run the diagnostic.
The synthesized azimuth reading is fluctuating outside acceptable parameters.
crane operator. Steady lift on that pallet.
Roger that. Moving it now. Keep the deck clear below.
All right, bring it forward. Watch the edge. Hold it steady. Set her down now. Watch your spacing on the starboard side. Coming left. Steady. All clear back here. All right, move this pallet to the starboard side. Copy that.
Coming through with the forklift. Stand clear.
Where do you want this one staged?
Stand by for launch. All systems green. Launch the aircraft. All hands, clear the flight deck.
Final checks complete.
Conduit secure. Verifying connection integrity.
Ensure the fit is secure on that conduit.
It's tight. Confirming connection now.
Pressure levels stabilizing.
Pressure levels are holding steady now.
Good. The adjustment seems to have worked. Monitor the levels closely.
Propulsion systems look nominal. Verify the starboard relay readings.
Readings checked. They are within tolerance.
What's the multimeter showing on the port side connection?
Fluctuation stabilized at 5 volts.